Hello and welcome back to this series of videos about GCP. Today I will start a new course called Essential Google Cloud Infrastructure Core Services, Episode 1. So I will go immediately to my browser here. Let's have a look to this. We have 3 hours to get in the league in the next in the promotion to the Diamond League. We have 400 points. We need 2,300. And these are nearly 1,000 points. It's so difficult to do 1,000 points in just 3 hours. Well, now I have my badges about all the courses I completed. So I have the first one, preparing, then the core infrastructure, which I recently achieved, and the one I achieved yesterday, the one about cloud infrastructure foundation. Okay. Therefore, sorry. We go to my learning path to continue with the next course, the one about the core services. Let's go. This is an 8 hours course. It will take me some videos. It's 600 points. Okay, it says 25 credits. So this course introduces participants to comprehensive and flexible infrastructure and platform services provided by Google Cloud with Compute Engine. Okay. Through a combination of video lectures, demos, and hands-on lab, participants explore and deploy solution elements, including infrastructure components such as network systems and application services. This course also covers deploying practical solutions, including customer-supplied encryption keys, security and access management, quotas and billings, and resource monitoring. So in this case, we have 1, 2, 3, 4 courses. Okay, let's go. Start module.
Hello, I'm Philip Meyer.
I cannot hear anything.
Hello, I'm Philip Meyer.
And I'm Elaine Biddle. We're both course developers at Google Cloud, and we want to welcome you to Architecting with Compute Engine, a series of 3 courses.
Before we start using all of the different services that Google Cloud Platform or GCP offers, let's talk about what GCP is. When you look at Google Cloud, you'll see that it's actually part of a much larger ecosystem. This ecosystem consists of open source software, providers, partners, developers, third-party software, and other cloud providers.
Google is actually a very strong supporter of open source software.
That's right. Now, Google Cloud consists of Chrome, Google Devices, Google Maps, Gmail, Google Analytics, G Suite, Google Search, and the Google Cloud Platform. GCP itself is a computing solution platform that really encompasses 3 core features: infrastructure, platform, and software.
This map represents GCP's global infrastructure. As of this recording, GCP's well-provisioned global network connects over 60 zones to over 130 points of presence through a global network of fiber optic cables.
And Google is continuously investing in this network with new regions, points of presence, and subsea cable investments. On top of this infrastructure, GCP uses state-of-the-art software-defined networking and distributed systems technologies to host and deliver your services around the world. These technologies are represented by a suite of cloud-based products and services that is continuously expanding.
Now, it's important to understand that there is usually more than one solution for a task or application in GCP. To better understand this, let's look at a solution continuum.
Google Cloud Platform spans from infrastructure as a service, or IaaS, to software as a service, or SaaS. You really can build applications on GCP for the web or mobile that are global, auto-scaling, and assistive, and that provide services where the infrastructure is completely invisible to the user. It is not just that Google has opened the infrastructure that powers applications like Search, Gmail, Google Maps, and G Suite. Google has opened all of these services that make these products possible and packaged them for your use.
Alternative solutions are possible. For example, you could start up your own VM in Google Compute Engine, install open source MySQL on it, and run it just like a MySQL database on your own computer in a data center.
Or you could use the Cloud SQL service, which provides a MySQL instance and handles operational work like backups and security patching for you using the same service as Google does to automate backups and patches.
You could even move to a NoSQL database that is auto-scaling and serverless so that growth no longer requires adding server instances or possibly changing the design to handle the new capacity.
This series of courses focuses on the infrastructure. An IT infrastructure is like a city infrastructure. The infrastructure is the basic underlying framework of fundamental facilities and systems such as transport, communications, power, water, fuel, and other essential services. The people in the city are like users, and the cars and bikes and buildings in the city are like applications. Everything that goes into creating and supporting those applications for the users is the infrastructure. The purpose of this course is to explore as efficiently and clearly as possible the infrastructure services provided by GCP.
Now, GCP offers a range of compute services. The service that might be most familiar to newcomers is Compute Engine, which lets you run virtual machines on demand in the cloud. It's Google Cloud's infrastructure as a service solution. It provides maximum flexibility for people who prefer to manage server instances themselves.
Google Kubernetes Engine lets you run containerized applications on a cloud environment that Google manages for you under your administrative control. Think of containerization as a way to package code that's designed to be highly portable and to use resources very efficiently. And think of Kubernetes as a way to orchestrate code in containers.
App Engine is GCP's fully managed platform as a service framework. That means it's a way to run code in the cloud without having to worry about infrastructure. You just focus on your code and let Google deal with all the provisioning and resource management. You can learn a lot more about App Engine in the Developing Applications with Google Cloud Platform course series.
Cloud Functions is a completely serverless execution environment or functions as a service. It executes your code in response to events, whether those events occur once a day or many times per second. Google scales resources as required, but you only pay for the service while your code runs. The Developing Applications with Google Cloud course series also discusses Cloud Functions.
Cloud Run, a managed compute platform that lets you run stateless containers via web requests or pub sub events. Cloud Run is serverless. That means it removes all infrastructure management tasks so you can focus on developing applications. It is built on Knative, an open API and runtime environment built on Kubernetes that gives you freedom to move your workloads across different environments and platforms. It can be fully managed on Google Cloud, on Google Kubernetes Engine, or anywhere Knative runs. Cloud Run is
The Architecting with Google Compute Engine courses are part of the Cloud Infrastructure Learning Path. This path is designed for IT professionals who are responsible for implementing, deploying, migrating, and maintaining applications in the cloud. The prerequisite for these courses is the Google Cloud Platform Fundamentals Core Infrastructure course, which you can find in the link section for this video. The Architecting with Google Compute Engine series consists of 3 courses.
Essential Cloud Infrastructure Foundation is the first course of the Architecting with Compute Engine series. In that course, we start by introducing you to GCP and how to interact with the GCP console.
Essential Cloud Infrastructure Core Services is the second course of this series. In that course, we start by talking about Cloud IAM, and you will administer identity and access management for resources. Next, we'll cover the different data storage services in GCP, and you will implement some of those services. Then we'll go over resource management, where you will manage and examine billing of GCP resources. Lastly, we'll talk about resource monitoring, and you will monitor GCP resources using Stackdriver services.
Elastic Cloud Infrastructure Scaling and Automation is the last course of the series. In that course, we start by going over the different options to interconnect networks to enable you to connect.
Now, our goal for you is to remember and understand the different GCP services and features, and also be able to apply your knowledge, analyze requirements, evaluate different options, and create your own services.
And that's why these courses include interactive hands-on labs through the Quick Labs platform. Quick Labs provisions you with a Google account and credentials. So
Let's go. So I will download this. Let's see if I still have in the memory. Remove that course. Yeah. So it's the 5th course in this learning path, and it's called Infrastructure Course Services. Okay, we'll download this and save it there. I'm not sure if I will ever use these PDFs, but I'm saving them all. Let's go.
in this module, we cover Cloud Identity and Access Management, or Cloud IAM. Cloud IAM is a sophisticated system built on top of email-like.
Okay, so this is the first of 4 sections. We have labs for all these modules, I think, yeah, like at least a couple labs. Oh, shit. Resource monitoring. Okay. I mean, we can try to make a surprise to this performing badger. Imagine if we reach 2,305 points.
Address names, job type roles,
go.
and granular permissions. If you're familiar with IAM from other implementations, look for the differences that Google has implemented to make IAM easier to administer and more secure. I will start by introducing Cloud IAM from a high-level perspective. We will then dive into each of the components within Cloud IAM, which are organizations, roles, members, and service accounts. I will also introduce some best practices to help you apply these concepts in your day-to-day work. Finally, you will gain first-hand experience with Cloud IAM through a lab. Let's get started with an overview of Cloud.
So, what is identity access management? It is a way of identifying who can do what on which resource. The who can be a person, group, or application. The what refers to specific privileges or actions, and the resource could be any Google Cloud service. For example, I could give you the privilege or role of Compute Viewer. This provides you with read-only access to get and list Compute Engine resources without being able to read the data stored in them. Cloud IAM is composed of different objects as shown on the slide. We're going to cover each of these in this module. To get a better understanding of where these fit in, let's look at Cloud IAM policies and the Cloud IAM resource hierarchy. Google Cloud resources are organized hierarchically, as shown in this tree structure. The organization node is the root node in this hierarchy. Folders are the children of the organization. Projects are the children of folders, and individual resources are the children of projects. Each resource has exactly one parent. The organization resource represents your company. Cloud IAM roles granted at this level are inherited by all resources under the organization. The folder resource could represent your department. Cloud IAM roles granted at this level are inherited by all resources that the folder contains. Projects represent a trust boundary within your company. Services within the same project have the same default level of trust.
Let's go.
Let's learn more about the organization node. As I mentioned earlier, the organization resource is the root node in the GCP resource hierarchy. This node has many roles, like the organization admin. The organization admin provides a user like Bob with access to administer all resources belonging to his organization, which is useful for auditing. There is also a project creator role, which allows a user like Alice to create projects within her organization. I am showing the project creator role here because it can also be applied at the organization level, which would then be inherited by all the projects within the organization. The organization node. As I mentioned earlier, the organization resource is the root node in the GCP resource hierarchy. This node has many roles, like the organization admin. The organization admin provides a user like Bob with access to administer all resources belonging to his organization, which is useful for auditing. There is also a project creator role, which allows a user like Alice to create projects within her organization. I am showing the project creator role here because it can also be applied at the organization level, which would then be inherited by all the projects within the organization. The organization resource is closely associated with a G Suite or Cloud Identity account. When a user with a G Suite or Cloud Identity account creates a GCP project, an organization resource is automatically provisioned for them. Then, Google Cloud communicates its availability to the G Suite or Cloud Identity superadmins. These superadmin accounts should be used very carefully because they have a lot of control over your organization and all the resources underneath it. The G Suite or Cloud Identity super administrators and the GCP organization admin are key roles during the setup process and for lifecycle control for the organization resource. The two roles are generally assigned to different users or groups, although this depends on the organization structure and needs. In the context of GCP organization setup, the G Suite or Cloud Identity super administrator responsibilities are: assign the organization admin role to some users, be a point of contact in case of recovery issues, control the lifecycle of the G Suite or Cloud Identity account and organization resource. The responsibilities of the organization admin role are: define IAM policies, determine the structure of the resource hierarchy, delegate responsibility over critical components such as networking, billing, and resource hierarchy through IAM roles. Following the principle of least privilege, this role does not include the permission to perform other actions, such as creating folders. To get these permissions, an organization admin must assign additional roles to their account. Let's talk more about folders, because they can be viewed as sub-organizations within the organization. Folders provide an additional grouping mechanism and isolation boundary between projects. Folders can be used to model different legal entities, departments, and teams within a company. For example, a first level of folders could be used to represent the main departments in your organization, like departments X and Y. Because folders can contain projects and other folders, each folder could then include other subfolders to represent different teams, like teams A and B. Each team folder could contain additional subfolders to represent different applications, like products 1 and 2. Folders allow delegation of administration rights. So for example, each head of a department can be granted full ownership of all GCP resources that belong to their department. Similarly, access to resources can be limited by folder, so users in one department can only access and create GCP resources within that folder. Let's look at some other resource manager roles, while remembering that policies are inherited from top to bottom. The organization node also has a viewer role that grants view access to all resources within an organization. The folder node has multiple roles that mimic the organizational roles, but are applied to resources within a folder. There is an admin role that provides full control over folders, a creator role to browse the hierarchy and create folders, and a viewer role to view folders and projects below a resource. Similarly, for projects, there is a creator role that allows a user to create new projects, making that user automatically the owner. There is also a project deleter role that grants deletion privileges for projects.
Okay, let's go.
Let's talk more about roles, which define the can do what on which resource part of Cloud IAM. There are three types of roles in Cloud IAM: basic roles, predefined roles, and custom roles. Basic roles are the original roles that were available in the Cloud Console, but they are broad. You apply them to a Google Cloud project, and they affect all resources in that project. In other words, IAM basic roles offer fixed, coarse-grained level of access. The basic roles are the owner, editor, and viewer roles. The owner has full administrative access. This includes the ability to add and remove members and delete projects. The editor role has modify and delete access. This allows a developer to deploy applications and modify or configure its resources. The viewer role has read-only access. Now, all of these roles are concentric. That is, the owner role includes the permissions of the editor role, and the editor role includes the permissions of the viewer role. There is also a billing administrator role to manage billing and add or remove administrators without the right to change the resources in the project. Each project can have multiple owners, editors, viewers, and billing administrators. GCP Services offers their own set of predefined roles, and they define where the roles can be applied. This provides members with granular access to specific GCP resources and prevents unwanted access to other resources. These roles are a collection of permissions, because to do any meaningful operations, you usually need more than one permission. For example, as shown here, a group of users is granted the instance admin role on project A. This provides the users of that group with all the compute engine permissions listed on the right, and even more. Grouping these permissions into a role makes them easier to manage. The permissions themselves are classes and methods in the APIs. For example, compute instance start can be broken down into the service, resource, and verb. That mean that the permission is used to start a stopped compute engine instance. These permissions usually align with the action's corresponding REST API. Compute engine has several predefined IAM roles. Let's look at 3 of those. The compute admin role provides full control of all compute engine resources. This includes all permissions that start with compute, which means that every action for any type of compute engine resource is permitted. The network admin role contains permissions to create, modify, and delete networking resources, except for firewall rules and SSL certificates. In other words, the network admin role allows read-only access to firewall rules, SSL certificates, and instances to view their ephemeral IP addresses. The storage admin role contains permissions to create, modify, and delete disks, images, and snapshots. For example, if your company has someone who manages project images, and you don't want them to have the editor role in the project, grant their account the storage admin role on that project. For the full list of predefined roles for Compute Engine, see the links section in the slides. Now, roles are meant to represent abstract functions, and are customized to align with real jobs. But what if one of those roles does not have enough permissions, or you need something even finer grained? That's what custom roles permit. A lot of companies use the least privilege model, in which each person in your organization is given the minimal amount of privilege needed to do their job. Let's say you want to define an instance operator role to allow some users to start and stop Compute Engine virtual machines, but not reconfigure them. Custom roles allow you to do that.
Let's go.
Let me show you how to create a custom role in GCP. My goal is to create an instance operator role that allows some users to start and stop Compute Engine virtual machines, but not reconfigure them. So here I am in the GCP console, and I'm going to click the navigation menu to go to IAM and admin. And specifically, I actually want to go to roles. And here I can see all the different roles that are available. Now, I could select one of these roles and create a role from that selection, and then either remove or assign more permissions. And you can see over here the permissions that are assigned to a role. Or I can just create a role from scratch. So let me go do that. I'm going to click Create Role, and I'm going to give it a name. I want to call this the instance operator. There's also an ID to that, and that must be unique and cannot be changed. There is a launch stage selection, alpha, beta, generability, and disabled. This is essentially just a launch stage. So you want to make sure that you start small, test it alpha, and then roll it out at some point so that other users know that they can leverage that availability. So what I'm going to do now is click Add Permissions, because currently there are no assigned permissions, given that I start from scratch. So let's go in here. And now we have over 2,000 different permissions. So we obviously want to filter for that just a little bit. And specifically, I'm interested in the permissions for compute instances. So let me type compute.instances. And hit enter. And now I'm down to 44. And so I want to select a couple different ones from here. I'm interested in get. I want to be able to get the different instances. I want to be able to list all of the instances, as well as reset them and resume. Resume is if an instance was suspended, which is sort of equivalent to if it's sleep or in standby mode. I also want to start and stop and suspend. So I can go click Add now, and I can see the permissions that I just assigned. So I can get, list, reset, resume, start, stop, and suspend. And from here, I can now click Create. And it's created that, and I can click on it here, and I can review that. I have an ID, and I have a launch stage, and these are my permissions. That's how easy it is to create a custom role in GCP. Alternatively, I could have started with the instance admin role as a base and removed the permissions that I don't want the role to have. Now, remember that custom roles are not maintained by Google. That means that when new permissions, features, or services are added to GCP, your custom roles will not be updated automatically.
Okay.
Let's talk more about members, which define the who part of who can do what on which resource. There are 5 different types of members: Google accounts, service accounts, Google groups, Google workspace domains, and cloud identity domains. A Google account represents a developer, an administrator, or any other person who interacts with Google Cloud. Any email address that is associated with a Google account can be an identity including gmail.com or other domains. New users can sign up for a Google account by going to the Google account sign-up page without receiving mail through Gmail. A service account is an account that belongs to your application instead of an individual end user. When you run code that is hosted on Google Cloud, you specify an account that code should run as. You can create as many service accounts as needed to represent the different logical components of your application. A Google group is a named collection of Google accounts and service accounts. Every group has a unique email address that is associated with that group. Google groups are a convenient way to apply an access policy to a collection of users. You can grant and change access controls for a whole group at once, instead of granting and changing access controls one at a time for individual users or service accounts. A workspace domain represents a virtual group of all the Google accounts that have been created in an organization's workspace account. Workspace domains represent your organization's internet domain name, such as example.com. And when you add a user to your workspace domain, a new Google account is created for the user inside of this virtual group, such as username at example.com. Google Cloud customers who are not workspace customers can get these same capabilities through Cloud Identity. Cloud Identity lets you manage users and groups using Google Admin Console, but you do not pay for or receive Workspace's collaboration products such as Gmail, Docs, Drive, and Calendar. Now, it's important to note that you cannot use IAM to create or manage your users or groups. Instead, you can use Cloud Identity or Workspace to create and manage users. A policy consists of a list of bindings. A binding binds a list of members to a role, where the members can be user accounts, Google Groups, Google Domains, and service accounts. A role is a named list of permissions defined by IAM. Let's revisit the IAM resource hierarchy. A policy is a collection of access statements attached to a resource. Each policy contains a set of roles and role members, with resources inheriting policies from the parent. Think of it like this. Resource policies are a union of parent and resource, where the less restrictive parent policy will always override the more restrictive resource policy. The IAM policy hierarchy always follows the same path as the Google Cloud resource hierarchy, which means that if you change the resource hierarchy, the policy hierarchy also changes. For example, moving a project into a different organization will update the project's IAM policy to inherit from the new organization's IAM policy. Also, child policies cannot restrict access granted at the parent level. For example, if we grant you the editor role for Department X, and we grant you the viewer role at the bookshelf project level, you still have the editor role for that project. Therefore, it is best practice to follow the principle of least privilege. The principle applies to identities, roles, and resources. Always select the smallest scope that's necessary for a task in order to reduce your exposure to risk. You can also use a recommender for role recommendations to identify and remove excess permissions from your principals, improving your resources security configurations. Each role recommendation suggests that you remove or replace a role that gives your principals excess permissions. At scale, these recommendations help you enforce the principle of least privilege by ensuring that the principals only have the permissions that they actually need. Their recommender identifies excess permissions using policy insights. Policy insights are ML-based findings about permission usage in your project folder or organization.
You can grant access to Google Cloud resources by allowing policies, also known as IAM policies, which are attached to resources. The allow policy controls access to the resource itself and any descendants of that resource that inherit the allow policy. An allow policy associates or binds one or more principals with single IAM role and any context-specific conditions that change how and when the role is granted. In the example on this slide, Gia is granted the organization admin predefined role, roles/resource manager.organization admin in the first role binding. This role contains permissions for organizations, folders, and limited projects operations. In the second role bindings, both Gia and Raha cloud resources by allowing policies, also known as IAM policies, which are attached to resources. The allow policy controls access to the resource itself and any descendants of that resource that inherit the allow policy. An allow policy associates or binds one or more principals with single IAM role and any context-specific conditions that change how and when the role is granted. In the example on this slide, Gia is granted the organization admin predefined role, roles/resource manager.organization admin in the first role binding. This role contains permissions for organizations, folders, and limited projects operations. In the second role bindings, both Gia and Raha are granted the ability to create projects via the project creator role, roles/resource manager.project creator. Together, these role bindings grant fine-grained access to both Gia and Raha. And Gia is granted more access than Raha. IAM deny policies let you set guardrails on access to Google Cloud resources. With deny policies, you can define deny rules that prevent certain principals from using certain permissions, regardless of consent. Together, these role bindings grant fine-grained access to both Gia and Raha. Together, guardrail deny. Deny policies are from using certain permissions, regardless of the roles they are granted. Deny policies are made of deny rules. Each deny rule specifies a set of deny principals that are denied permissions and the permissions that the principals are denied or unable to use. Optionally, you can define the condition that must be true for the permissions to be denied. When a principal is denied a permission, they can't do anything that requires that permission regardless of the IAM roles they have been granted. This is because IAM always checks relevant deny policies before checking relevant allow policies.
IAM conditions allow you to define and enforce conditional attribute-based access control for Google Cloud resources. With IAM conditions, you can choose to grant resource access to identities, members, only if configured conditions are met. For example, this can be done to configure temporary access for users in the event of a production issue, or to limit access to resources only for employees making requests from your corporate office. Conditions are specified in the role bindings of a resource's IAM policy. When a condition exists, the access request is only granted if the condition expression evaluates to true. Each condition expression is defined as a set of logic statements allowing you to specify one or more attributes to check. An organization policy is a configuration of restrictions, defined by configuring a constraint with the desired restrictions for that organization. Organization policy can be applied to the organization node, and all folders or projects within that node. Descendants of the targeted resource hierarchy inherit the organization policy that has been applied to their parents. Exceptions to these policies can be made, but only by a user who has the organization policy admin role. What if you already have a different corporate directory? How can you get to your users and groups into Google Cloud? Using Google Cloud Directory Sync, your administrators can log in and manage Google Cloud resources using the same usernames and passwords that they already use. This tool synchronizes users and groups from your existing Active Directory or LDAP system with users and groups in your cloud identity domain. The synchronization is one-way only, which means that no information in your Active Directory or LDAP map is modified. Google Cloud Directory Sync is designed to run scheduled synchronizations without supervision after its synchronization rules are set up. Google Cloud also provides single sign-on authentication. If you have your own identity system, you can continue using your own system and processes with SSO configured. When authentication is required, Google will redirect to your system. If the user is authenticated in your system, access to Google Cloud is given. Otherwise, the user is prompted to sign in. This allows you also to revoke access to Google Cloud. If your existing authentication system supports SAML2 SSO, configuration is as simple as 3 links and a certificate, as shown on the slide. Otherwise, you can use a third-party solution like ADFS, Ping, or Okta. Also, if you want to use a Google account but are not interested in receiving mail through Gmail, you can still create an account without Gmail.
As mentioned earlier, another type of member is a service account. A service account is an account that belongs to your application instead of to an individual end user. This provides an identity for carrying out service-to-service interactions in a project without supplying user credentials. For example, if you write an application that interacts with Google Cloud Storage, it must first authenticate to either the Google Cloud Storage XML API or JSON API. You can enable service accounts and grant read-write access to the account on the instance where you plan to run your application. Then program the application to obtain credentials from the service account. Your application authenticates seamlessly to the API without embedding any secret keys or credentials in your instance, image, or application code.
Service accounts are identified by an email address, like the example shown here. There are 3 types of service accounts: user-created or custom, built-in, and Google API service accounts. By default, all projects come with a built-in Compute Engine default service account. Apart from the default service account, all projects come with a Google Cloud API service account, identifiable by the email project-number@cloudservices.gserviceaccount.com. This is an account designed specifically to run internal Google processes on your behalf and is automatically granted the editor role on the project. Alternatively, you can also start an instance with a custom service account. Custom service accounts provide more flexibility than the default service account, but they require more management from you. You can create as many custom service accounts as you need, assign any arbitrary access scopes or Cloud IAM roles to them, and assign the service accounts to any virtual machine instance. Let's talk more about the default Compute Engine service account. As I mentioned, this account is automatically created per project. This account is identifiable by the email project-number-compute@developer.gserviceaccount.com and is automatically granted the editor role on the project. When you start a new instance using gcloud, the default service account is embedded on that instance. You can override this behavior by specifying another service account or by disabling service accounts for the instance. Now, authorization is the process of determining what permissions an authenticated identity has on a set of specified resources. Scopes are used to determine whether an authenticated identity is authorized. In the example shown here, applications A and B contain authenticated identities or service accounts. Let's assume that both applications want to use a cloud storage bucket. They each request access from the Google authorization server, and in return, they receive an access token. Application A receives an access token with read-only scope, so it can only read from the cloud storage bucket. Application B, in contrast, receives an access token with read-write scope, so it can read and modify data in the cloud storage bucket. Scopes can be customized when you create an instance using the default service account as shown in the screenshot. These scopes can be changed after the instance is created by stopping it. Access scopes are actually a legacy method of specifying permissions for your VM. Before the existence of IAM roles, access scopes were the only mechanism for granting permissions to service accounts. For user-created service accounts, use Cloud IAM roles instead to specify permissions. Now, roles for service accounts can also be assigned to groups or users. Let's look at the example shown on the slide. First, you create a service account that has the instance admin role, which has the permissions to create, modify, and delete virtual machine instances and disks. Then, you treat the service account as a resource, and decide who can use it by provisioning users or a group with the service account user role. This allows those users to act as that service account to create, modify, and delete virtual machine instances and disks. Users, who are service account users for a service account, can access all of the resources that that service account has access to. Therefore, be cautious when granting the service account user role to a user or group. Here's another example. The VMs running component 1 are granted editor access to project B using service account 1. The VMs running component 2 are granted object viewer access to bucket 1 using an isolated service account 2. In this way, you can scope permissions for VMs without recreating VMs. Essentially, Cloud IAM lets you slice up a project into different microservices, each with access to different resources, by creating service accounts to represent each one. You assign the service accounts to the VMs when they are created, and you don't need to ensure the credentials have been managed correctly because Google Cloud manages security for you. Now, you might ask, how are service accounts authenticated?
There are 2 types of service account keys. By default, when using service accounts within Google Cloud, for example, from Compute Engine or App Engine, Google automatically manages the keys for service accounts. However, if you want to be able to use service accounts outside of Google Cloud or want a different rotation period, it is possible to also manually create and manage your own service account keys.
All service accounts have Google managed key pairs. With Google managed service account keys, Google stores both the public and private portion of the key and rotates them regularly. Each public key can be used for signing for a maximum of 2 weeks. Your private key is always held securely in escrow and is never directly accessible. You may optionally create one or more user-managed key pairs, also known as external keys, that can be used from outside of Google Cloud. Google only stores the public portion of a user-managed key. The user is responsible for the security of the private key and performing other management operations such as key rotation, whether manually or programmatically. Users can create up to 10 service account keys per service account to facilitate key rotation. User-managed keys can be managed by using the Cloud IAM API, G-Cloud command line tool, or the service account page in the Cloud Console. Google does not save your user-managed private keys, so if you lose them, Google cannot help you recover them. You are responsible for keeping these keys safe, and also responsible for performing key rotation. User-managed keys should be used as a last resort. Consider the other alternatives, such as short-lived service account credentials, tokens, or service account impersonation. The G-Cloud command shown on the slide is a fast and easy way to list all of the keys associated with a particular service account.
Let's talk now about organization restrictions. The organization restrictions feature lets you prevent data exfiltration through phishing or insider attacks. For managed devices in an organization, the organization restrictions feature restricts access only to resources in authorized Google Cloud organizations. There is a need in organizations to restrict access of their employees only to resources in authorized Google Cloud organizations. Google Cloud administrators who administer Google Cloud and egress proxy administrators who configure the egress proxy engage together to set up organization restrictions. The managed device is governed by the organizational policies of a company. Employees of an organization use a managed device to access the organization resources. An egress proxy administrator configures the proxy to add organization restrictions headers to any requests originating from a managed device. This proxy configuration prevents users from accessing any Google Cloud resources in non-authorized Google Cloud organization. The organization restrictions feature in Google Cloud inspects all requests for organization restrictions header and allows or denies the requests based on the organization being accessed. Organization restrictions can be used to restrict access to employees in your organization so that employees can access resources only in your Google Cloud organization and not other organizations. They can also be used to allow your employees to read from cloud storage resources, but restrict employee access only to resources in your Google Cloud organization, or allow your employees to access events.
Let's talk about some Cloud IAM best practices to help you apply the concepts you just learned in your day-to-day work.
Then we have the lab.
First, leverage and understand the resource hierarchy. Specifically, use projects to group resources that share the same trust boundary. Check the policy granted on each resource and make sure you recognize the inheritance. Because of inheritance, use the principle of least privilege when granting roles. Finally, audit policies using cloud audit logs and audit memberships of groups using policies. Next, I recommend granting roles to groups instead of individuals. This allows you to update group membership instead of changing a Cloud IAM policy. If you do this, make sure to audit membership of groups used in policies and control the ownership of the Google group used in Cloud IAM policies. You can also use multiple groups to get better control. In the example on this slide, there is a network admin group. Some of those members also need a read-write role to a cloud storage bucket, but others need the read-only role. Adding and removing individuals from all three groups controls their total access. Therefore, groups are not only associated with job roles, but can exist for the purpose of role assignment. Here are some best practices for using service accounts. As mentioned before, be very careful when granting the service account's user role, because it provides access to all the resources that the service account has access to. Also, when you create a service account, give it a display name that clearly identifies its purpose, ideally using an established naming convention. As for keys, establish key rotation policies and methods and audit keys with the serviceaccount.keys.list method. Finally, I recommend using Cloud Identity Aware Proxy, or Cloud IAP. Cloud IAP lets you establish a central authorization layer for applications accessed by HTTPS, so you can use an application-level access control model instead of relying on network-level firewalls. Applications and resources protected by Cloud IAP can only be accessed through the proxy by users and groups with the correct Cloud IAM role. When you grant a user access to an application or resource by Cloud IAP, they're subject to the fine-grained access controls implemented by the product in use without requiring a VPN. Cloud IAP performs authentication and authorization checks when a user tries to access a Cloud IAP secured resource, as shown on the right.
Let's go.
It's time to apply what you learned. In this lab, you'll grant and revoke roles to change access. Specifically, you will use Cloud IAM to implement access control, restrict access to specific features and resources, and use the service account user role. Now, anytime you make changes to IAM roles, the GCP console refreshes faster than the actual system. Therefore, you should expect some short delays.
Let's start this set of tasks. Therefore, okay, going to. Oh shit. So I have student one. Start. Okay, so I have the access to the first account. Now, Open another tab in incognito window. Ah, fuck. Add account. Oh, okay. Add account. Some points I use sign out. Okay. So never log out. Understand. Okay, so the second is orange, the first is green. Explore the IAM console. Make sure you add username 1. Let's go to IAM, click grant access. What the fuck is IAM? Grant access and explore the roles in the drop-down menu. Note the various roles associated with each resource by navigating the roles menu. Grant access. Select a role. So it's saying, okay, to explore roles associated with each resource. So for example, RPG or AutoML BigQuery has its own set of roles. Then we have Cloud Build with its set of roles. So cancel. Switch to second username. Let's go to IAM, browse the list for the lines with the names associated with you. Browse the list. Browse the list for the lines with the names associated with your name. Quick Labs connection test dialog. Okay. So let's go to IAM. So this is the user ending in 64 CFF. The first one ends in F60A. F60A 64 CFF. So I can go here, unit permissions. As I am the second user, I cannot do anything because I just have access to the project, but not the owner role. Switch back to the username one. Okay, so here instead I have it, and I can go. Okay, principal viewer. Okay. Prepare a resource for access testing. So I will go to username one, create a cloud storage bucket. I will name it like this. Multi-regional cloud storage bucket. If you see okay, click upload and select upload file from the top down. Upload any sample file from your local machine. When the file has been uploaded, click on 3 dots at the end of the line containing file and click rename. Okay. So I will just create in documents. Oh shit. And new text. For example, txt. Upload files. Sample txt. Okay. Rename. Oh, from here. Let's go. Verify project viewer access. Switch to username too. Let's see if I can see the packet. Yeah, I can see it. Remove project access. So I go to username 1, select and remove access. Verify you remove access or you accidentally remove access. Okay. So from go to IAM. Who the fuck is IAM? I always lose it. Select username 2 and click remove access. From where remove access? If you want to remove, they will lose fear. What is the user? It's appear from the list. The user has no access now. Great. Verify the user has lost access. How do I verify that? So I go to the cloud overview and then to the compute engine, to the packets. Bad. The fuck, man? Why it's not disappearing? This refresh. Oh, fuck you. Okay, has not access to the project. Add storage access. Copy the value of username 2 from the quick labs connection detail. Switch to username 1. Navigate IAM, grant access. So grant access. And for new principal, paste username 2 and select as role storage object viewer. Storage. Fucking Jesus Christ. Storage. Object. Object. Okay. saved it. Check my progress. Let's go. Switch to 0.2. Doesn't have project view roles, so that user can see the project of any resource in the console. It has only access to cloud storage. Therefore, we go to Cloud Shell. And we do an export my bucket, and we put the name of the project ID. Show my bucket. Okay, so bucket works. So cloud storage, LSGS. Authorize. Okay, so I listed the files in this bucket. So the rest, as you can see, it has limited access. Okay, the rest of the lab is performed on the username one cloud switch. Okay, so I can close this. Switch to the username one cloud console tab. Set up the service account user. Service accounts, create service accounts, specify service account name as read bucket objects. So we go to service accounts, create service account name, create and continue. Select cloud storage object viewer. Viewer. Okay. Continue and done. Add the user to the service account. Select the read back to your service account. Click on the three dots to the right of the service account name and click Manage Permissions. You will grant the user role account to the service, which allows that person to use a service account on a VM if they have access to the VM. You could perform this activity for a specific user group domain for training purposes. You will grant the service account user to everyone at the company called Altostrat. Altostrat is a fake company used for demonstration training. So click on the grant access button and specify and leave the remaining settings as their defaults. Okay. Service account user. What? Role, service account user. Then save. Okay. So grant compute engine access, grant access. Compute engine instance admin v1. V1. Okay. Click save. And this step is a rehearsal of the activity you will perform for a specific user. This action gives the user limited abilities with the VM instance. The user will be able to connect the SSH to a VM and perform some administration tasks. Instance admin and service account user. Okay. Therefore, we'll create this compute engine VM instance. Create an instance. And we'll test the IAM policy demo IAM. US East 1. The E2 micro Debian Linux. Read bucket objects. Okay. Set access for each API, read write. Create okay. Service account. Okay. So before I didn't grant the user role on the service account, I did something strange. Maybe just assign the user service account user role on another scope to the same principle. By the way, let's go in that virtual machine we created and we list the compute instances. Oh shit, no, cancel what I'm doing. Compute engine VM instances, SSH. Now this machine is using this service account, which will allow this command to work. Oh no. So sorry, I didn't share with you the SSH. Okay, so I just launched the command and it didn't work. So it was expected. What happened? Why? Another train is part of the command below it. Let's copy to this location. Let's see. So my packet name was named as the project ID. Okay, so we completed the following. We use move to rename file to copy the rename file back to the packet. Okay. Okay, well, it doesn't have permission to access. Okay. Now what happened? Because you connected via SSH to the instance, you can access the service account, essentially assuming the same permission. The service account the instance was started with had the storage viewer role, which permits downloading objects from JS bucket in the project. To list instances in a project, you need to grant the compute instance list permission. Because the service account did not have this permission, you could not list instances running in the project. Because the service account did have permission to download objects, it could download objects. It did not have permission to write objects, so you got a 403 access denied message. So we go to IAM, we go objects, click on the pencil. And it has the storage object viewer role. Alter the role to cloud storage object creator. Okay, so now I need to go to IAM. We just close this. Storage object viewer. I will alter the role to storage object creator. Okay. Save. Now return to SSH window. To copy your name file back to the bucket, run the following command. Okay, now we did it. So this time the command succeeded. So now review. But we took some time to complete it. Okay. We completed the lab review exploring. Okay.
In this lab, you granted and revoked Cloud IAM roles, first to a username too. If I have provided the right permissions. Now we have warned in the modules that sometimes the permissions upload faster than will be displayed.
Okay, quiz identity and access management. Which of the following is not a type of IAM role, custom, basic, predefined? and advanced. Which of the following is not a type of IAM member? Service account, cloud identity, domain, organization account, Google account, Google group, Google Express domain, organization account. What abstraction is primarily used to administer user access in IAM? An abstraction used to administer user access in IAM. What does this mean? User access. What the fuck does it mean? Going back to the letters of this one. Retake. So it wasn't privileges. What the fuck? It's not credential. You want to know? User credentials. Okay. IAM administration uses predefined roles for administration of user access. The roles are defined by permissions, but permissions are not applied to users directly, only through the roles that are assigned to them. Okay, so the abstraction is the role. Fuck them. And I couldn't understand the question.
In this module, we covered identity and access management, along with its components and best practices. IAM builds on top of other Google Cloud Identity services. The creation and administration of corporate identities occurs through the Workspace Admin or Cloud Identity Interface and is commonly handled by a person separate from the Google Cloud Administrator. Google Groups are a great way for these two business functions to collaborate. You establish the roles and assign them through the group, and then the Workspace Admin administers membership in the group. Finally, remember that service accounts are very flexible and that they can enable you to build an infrastructure-based level of control in your application.
Let's go.
In this module, we cover storage and data.
So we have this new module. I am already recording since 1 hour. Therefore, I will just stop the video here. Unfortunately, will not be able to arrive to 2,300 points. As we are talking, we still have 2 hours remaining. It will be possible, but I have other tasks during the day, and Performing Badger is still doing points. He's not stopping there. He's not sleeping. Therefore, it's also a moving target. He's 500 points forward. I started the live with, I don't know how much was that, around 600. So I did 200 in 1 hour. Yeah, it will be possible, but I have a life to live. And it's not granted that putting this effort will lead to the promotion. Therefore, I will just continue watching to my own
In this module, we cover
path. Thank you very much. See you in the next video.